please. Parallelograms should be visible. I should see everybody's hands making parallelograms. You got your supply sheet? Yeah, so you have to start making your parallelogram.
I don't have any. I just. Didn't she say block per person?
Yes.
Michael, put the gum away. You're not chewing it right now, are you? Because ice tips over. Go throw it away.
Unfortunately, that's not quite a parallelogram because, let's see if we can get you another
I just can't wait until I step in that.
Oliver, trade me. As close as you can get, yeah.
So what are you doing?
Guys, make sure that when you're building your parallelogram, that the two long sides are opposite of each other, and that the two short sides are opposite of each other. That is very important here. Perfect.
Yeah, I do.
Let's get, I think you've got long straw there. Let me get you.
You're like a campaign run. I don't know that much. All I know is that they have
How's it going, guys? Are you okay? Perfect.
Dude, there was a tornado.
Yeah, there was.
Yeah, there was a tornado. Yeah, there was. Yeah, in Indiana.
Some of our power went out. Some of my power.
They live more than Trump. Dude, there was a hit. Dude, you see there's hail before tornadoes. Yeah, I did see hail. I saw the hail. It was like this big. No, it was like quarter hail.
These two sides are pretty close. Emma, try to keep us together. Try trading them for this one. There's a real waste to All right, raise your hand if you're still working on your parallelogram. Let's Let's try that again because absolutely nobody listened. Class, oh class?
Yes, oh yes.
Raise your hand if you are still working on your parallelogram. So I've got a few people finishing up, so I'm going to give them just a minute or so more. If you're done, look at the parallelogram. It's such a hard word to say. I want you looking at your parallelograms, and I want you thinking about what you know about parallelograms. I know this is a shape that you guys have discussed in the past, correct?
Yes.
Okay, so this is not a brand new shape to you, but we're just
Eric,
coming
is that
back
what you're
to
supposed
it.
to have made?
So you guys are welcome to talk among your table groups about what you know about parallelograms. Alrighty, class. Michael? Thank you. Alright guys, so now I want you to take your parallelogram. So you've got, right now it's just a rectangle. You're going to take the top, you're going to take the opposite corners and you're just going to pull it a little bit so it makes that parallelogram shape like I have here on the board. So you can see it like this. I've got mine right here. Now I want you to look at your parallelogram. What kind of things do you notice about your parallelogram? What kind of things do we notice about the parallelogram?
Both sides are parallel.
The sides are parallel. Very important. Ooh, nobody should be talking right now. sides are parallel. What else do we notice, Vanessa?
The 4 sides.
There are 4 sides to my parallelogram. What else do we notice? Sam?
Right angles.
You said no right angles?
Yeah,
No right angles. However, something I'm going to point out, their parallelograms are shapes where there are 4 sides. You can call them a quadrilateral. Another word for parallelogram is a quadrilateral, because quad means 4 sides. So we see these, there are no right angles. But what shapes do we know that have 4 sides? Megan?
A square.
A square does have 4 sides, and all of the sides are parallel to each other. Is that a parallelogram, Brock? Do you think? Yes or no? Looking at it. So it has 4 sides. You say no, why do you say no?
Because
Michael, will you grab that, please?
a parallelogram has no right angles.
Actually, parallelograms can have right angles. Both squares and rectangles are parallelograms. So I'm going to note that down. So actually, I'm going to erase this no right angles fact because that's not always true. And I'm going to write that squares and rectangles are parallelograms. Perfect. And I'm going to also write that they can be called quadrilaterals. Quad meaning 4. Quad. Forgot how. Should have remembered how to spell this before I wrote that down there. Okay, now with these parallelograms, if you take your shape, if you take your parallelogram, make it back into a rectangle. Make it into a rectangle. So everybody, looking at your rectangle. I'll wait till I see everybody holding it up, showing me a rectangle. Bless you. All right, so here's my rectangle. Now I want you to I want you to look at the perimeter. We didn't measure this perimeter, but just take a peek at the perimeter. And now what I want you to do is I want you to take one corner, and I want you to take the other corner and pull it to turn it back into that parallelogram shape that we see on the board. Now, my first question to you is, not around your neck, Michael, doing it appropriately. I want you to tell me, did the perimeter, the area around the shape, the length of those sides, did that change or did that stay the same? Raise your hand if you think it stayed the same. All right, got a few people for stay the same. Raise your hand if you think that the area just around the outside changed. Raise your hand if you think it changed. And then I have some people not voting. The correct answer is yes. The area stayed the same because we didn't do anything. We didn't cut anything off or make anything longer. We just adjusted the shape of it. So no matter what way I turn this shape, my area is still going to be, my perimeter, very important to say that, perimeter, the area around the outside, still the same length because I did not cut off and I did not add on. I just changed the shape. Now my next question to you is, when I have my rectangle, and then if I change the shape, change it like this, did the area, the space inside, did that change? Owen, do you say yes or no? You say no? Why do you say no?
Because it's still the exact same amount of space inside of it.
You say
You're just pulling one side to the other.
Okay. He says no. Does anybody agree that it's no? A few people do. Does anybody agree that or does anybody think that the area inside did change? Several people are saying that it did change. Guys, the correct answer? It did change. And let me tell you why. What was the formula for the area of a rectangle? Do you remember? I was asking Merrick. Merrick? Length times width. Length times width. So if I've got my rectangle here, looking at your rectangle, guys. Looking at my rectangle, my length times my width. Now, if I change that, look, I've got the same perimeter, but look how skinny that is. Doesn't that look, you can just see that it looks a lot smaller. But now my length is the same, but my width has changed.